So here's a look at how to enter this data into our calculator to have our calculator perform the hypothesis test for us. We're going to use the one-prop z-test, which is fairly easy to find under our tests menu. So we go to stat tests, and one prop z test, you remember there's also one prop z int, which is for computing the confidence interval. This is what we're going to use to perform the hypothesis test. And we enter these values, p0, which is our a null hypothesis, right? The value from our null hypothesis. A value for x, number of successes. A value for n, the total trials in our sample. And for the alternative hypothesis, we'll enter something of the form either less than p0, greater than p0, or not equal to p0. We'll enter one of those values, or one of those forms of the alternative hypothesis. And that's just telling it which type of tail to compute. Do you compute a left tail, a right tail, or a two-tail? And then the output that you'll get will include a z-value, which is your test statistic, and a p-value. It'll tell you p, but that'll be our p-value. And then it'll also give us some other things that that are from the sample, some other statistics that go with the sample. But these are going to be the values that we want to use. In particular, the test statistic and the p-value will be used to help us determine whether or not we want to reject our null hypothesis or fail to reject our null hypothesis. In a 2016 Gallup poll, 34% of people said that it was morally acceptable to clone animals. In 2017, a survey found that 192 out of 600 randomly selected people believed that it was morally acceptable to clone animals. Thinks that percentage now may be lower. Use a 0.10 significance level to test the claim that 34% of all adults say that it is morally acceptable to clone animals. And for this one, I'm going to use, just like all the other examples, I'm going to use the p-value method. And in this case, what I might do here to compute the test statistic and p-value is just enter these data into my calculator and have my calculator do it for me. But first, let's write our null hypothesis and our alternative hypothesis. The null hypothesis, let's read that first sentence here, was based on this past data from a poll in 2016 that found 34% found it morally acceptable to clone animals. So let's use that for our population proportion, p. So we're going to claim for our null hypothesis that p is 0.34. We want to see that based on this survey where we found 192 out of 600 believed that it was morally acceptable to clone animals. We want to see if this value has gone down at all, right? Because here we want to know if that percentage now may be lower. So now I'm going to take the sample data that we have, where here we see 192 and 600 altogether. So 192 people said it was morally acceptable, and 600 people altogether were sampled. And so we're going to enter this stuff into our calculator. So we'll go to Stat, and then scroll down to the Tests menu. And then the fifth one down the menu will be the one that we use, one prop z-test. Okay, and this is going to have us enter a few things. First, we want to enter something for p0. That's going to be the value that we're stating here in our null hypothesis. Okay, the next thing we'll enter is the value for x, which was the number of people that said they found it morally acceptable, 192. The next thing we'll enter is a value for n, which is the sample size of 600. And then below that we have the form of our alternative hypothesis, which in this case it's less than 0.34. So we'll make sure we use the less than symbol there for that one. Okay, so these are going to be the values that we're going to enter into our calculator function. And then what will happen is it'll spit out a value for the test statistic and for the p-value. So in this case, for the test statistic, first thing it gives me is negative 1.034. And for the p-value, would be the thing that it gives me right below that. It gives me 0.1505. Now let's think about how we can interpret these values. So again, the p-value that we got, which corresponds to this particular region, right? So we had that z-score of negative 1.034. So the p-value being the area of that region that we get here was 0.150. So that was the p-value that we got. And since we had a significance level of 0.10, how would the p-value compare with that? In this case, the p-value was 0.1505 and the significance level 0.10. Notice that the p-value we got was bigger. And so the conclusion is that we're going to fail to reject our null hypothesis. And an important thing would be to now make a conclusion about that. Since we're failing to reject, the conclusion is that we don't have enough evidence to support the alternative hypothesis. That P0, that the population proportion is less than 0.34. Okay, and in this case, whenever we fail to reject, we consider that to be an inconclusive result. In general, we will only get inconclusive result. We will only get a conclusive result when we are able to reject the null hypothesis. But in this case, since we failed to reject, we weren't able to get a conclusive result. So the big question, is this statistically significant? Okay, in other words, when observed results are unlikely under the assumption that the null hypothesis is true and we reject the null hypothesis, right? So only in the case when we reject the null hypothesis are we able to say that it's statistically significant. So rejecting H0 allows us to support H1, in which case then we have a good reason to say that H0 is not true and H1 is probably true. On the other hand, failing to reject, we get something that's more inconclusive.